This is beyond the business. Disclaimer.
Let's start with a simple question. What are rare earth materials and why do they matter so much today? These elements rarely appear in everyday conversations, yet they quietly sit inside almost everything that defines modern life. From electric motors and wind turbines to smartphones, data centers, and industrial automation, rare earths are part of the hidden layer that allows technology to function. They are not a future resource, they are a present dependency. Our daily routines already rely on them, so does the direction of the energy transition, digital infrastructure, and advanced manufacturing. This episode is not about hype or alarm, it is about clarity. Where these materials come from, how they move through global supply chains, who depends on them, and why their role will only grow as systems become more electrified and more connected. Rare earths are often described as a strategic resources, but in practice they are something even more basic. They are part of the physical foundation of the modern economy, shaping not only how we build technology today, but how we will scale it tomorrow. So before we talk about markets, politics, or risks, we start with the basics. What they are, where they are found, and how extraction defines the first layer of the story. Rare earth elements are not rare in the geological sense. They are widely dispersed across the Earth's crust. What makes them complex is not their presence, but their concentration. Finding deposits rich enough to extract economically is difficult, and separating individual elements from ore requires energy intensive processes. Today, mining is geographically concentrated. China remains the dominant producer with major operations in Inner Mongolia and Sichuan. The United States extracts rare earths at Mountain Pass in California. Australia operates large scale mining through sites like Mount Weld. Additional production exists in Myanmar, Vietnam, and small number of other regions, but globally supply is still structurally centered around a limited set of locations. China today accounts for roughly 60 to 70% of global rare earth mining and close to 90% of processing capacity, which makes the supply chain highly concentrated from extraction to refining. In Europe, deposits exist, but large scale extraction is limited. Exploration continues in countries such as Sweden and Norway, yet most industrial demand is still met through imports rather than domestic production. Mining rare earths is not a low impact activity. Ore is typically processed using crushing, grinding, and chemical separation, often involving acids and large volumes of water. The process generates tailings, waste materials, and emissions, particularly where older or less efficient technologies are used. This creates a structural paradox. Materials essential for wind turbines, electric motors, electronics, and digital infrastructure are still extracted through processes that remain resource intensive and environmentally demanding. Technology is improving, new projects increasingly integrate closed loop water systems, better waste management, and stricter environmental controls. But mining remains an industrial activity with a visible footprint, and the environmental cost is part of the physical reality of the supply chain. Because of this concentration, rare earth supply is not only a resource issue, but a strategic one. Disruptions in production, export policy, or logistics can translate directly into industrial delays, price volatility, and geopolitical leverage across technology and energy markets. Rare earth mining, therefore, sits at the very beginning of a long value chain, before the magnets, before the electronics, before the clean technologies. There is an extraction, a process that anchors the entire system in physical reality. If mining is the foundation of the rare earth story, processing is where the real leverage begin. Rare earth elements rarely move directly from mine to factory. After extraction, the ore must be separated into individual elements through a complex chemical processes. This stage is technologically demanding, capital intensive, and tightly regulated because of the environmental and technical complexity involved. And this is where the global supply chain becomes highly concentrated. Today, China dominates not only in mining but more importantly, refining and separation. While its share of global mine production is estimated at roughly 60 to 70%, its share of processing capacity is far higher, approaching around 90% of global refining. This distinction matters because having deposits in the ground does not automatically translate into supply independence. If the processing stage is controlled elsewhere, the value chain and the decision power remains concentrated. In practical terms, this means that even when rare earths are mined in the United States or Australia, they may still depend on processing infrastructure connected to Chinese industrial capacity or technology. So, the strategic reality of rare earths is not simply about geology, it is about industrial ecosystems. Separation facilities, technical know how, environmental permitting, skilled labor, and chemical supply chains all create barriers to rapid diversification. Building new refining capacity takes years, not months, which reinforce the structural role of existing hubs. This is why rare earths are often described as geopolitical resource, not because they are scarce in nature, but because the chain that transforms them into usable materials is concentrated and difficult to replicate quickly. Rare earth separation is not just another industrial step. It requires complex chemical processing, specialized facilities, and strict environmental controls, making new capacity slow, expensive, and politically sensitive to develop. Today, close to 90% of global refining capacity is concentrated in one geography. That concentration turns processing into a structural choke point rather than a simply manufacturing stage. In practical terms, this affects prices, delivery timelines, and supply stability for entire industries, from automotive and electronics to energy infrastructure. When processing capacity tightens, the ripple effect moves quickly through global markets. Rare earths, therefore, illustrate a broader principle of the modern economy. Control does not necessarily sit where resources are found, but where they are transformed into usable materials. And this is what gives the rare earth supply chain its strategic weight. The critical leverage lies not in the ground, but in the conversation step that makes modern technology possible. Once we move from geography to industry, the picture becomes more clear. Rare earth supply is not just concentrated, it is organized around a small number of key players. Globally, the mining landscape is still dominated by China, but the corporate structure behind the supply chain tells a more precise story. In the United States, MP Materials operates the Mountain Pass mine in California. It is the largest rare earth producer in North America and represents a strategic effort to rebuild a domestic supply chain. Yet, even here, the broader challenge remains mining alone does not equal independence without refining capacity. In Australia, Lynas Rare Earths plays a pivotal role. It is currently the largest non Chinese rare earth producer with integrated processing operations, including facilities in Malaysia. Lynas has become a central anchor for supply diversification, especially for customers seeking alternative to Chinese refining. Inside China, the industry is structured around large state linked groups, with companies such as China Northern Rare Earth acting as the major industrial hubs. These entities operate across mining, separation, and distribution, giving them influence not only over supply volumes but also over pricing dynamics. Today, China controls roughly 60-70% of global rare earth mining and close to 90% of refining capacity. which means that even when raw material is extracted elsewhere, processing often still flows through Chinese infrastructure. And this concentration explains why rare earths are not just a commodity market, they are a network with a small number of decision nodes where operational choices made by a few companies, which can ripple across global manufacturing. For manufacturers, the implication is structural. Automotive producers, electronic firms, defense contractors, and renewable technology suppliers are not only dependent on the materials itself, but on the stability of a tightly interconnected industrial chain. And that leads to a simple but important conclusion. Rare earth supply is not controlled at the point of extraction alone, it is shaped at the intersection of mining, processing, and industrial scale. And today, that intersection remains concentrated in very few hands. Rare earth materials don't stay at the mining stage for long. Once processed and separated, they move into industrial bloodstream of the global economy. Their largest destination is permanent magnets. Around 70-80% of certain rare earth elements end up in high performance magnets used in electric motors, wind turbines, robotics, and precision manufacturing. These magnets are what allow machines to be smaller, lighter, and more energy efficient. Without them, modern electrification would look very different. Beyond magnets, rare earths flow into consumer electronics, data infrastructure, and defense systems. Smartphones, servers, sensors, medical equipment, and industrial automation all rely on specific elements for performance and miniaturization. In practical terms, this means rare earths are not tied to one sector, they sit across the entire industrial spectrum. On the corporate side, demand is concentrated among large technology, automotive, and industrial manufacturers. Companies such as Tesla, Bosch, Siemens, General Electric, and major electronics producers depend on stable access to magnet supply chains for motors, turbines, and advanced components. Automotive electrification alone has significantly increased demand. An electric vehicle can require from 1 to 2 kilos of rare earth materials in its motor system, depending on design. Wind energy adds another layer. A single offshore wind turbine can use hundreds of kilograms of rare earth based magnet material. So, when we talk about demand, we are not talking about niche usage, we are talking about foundational inputs for modern infrastructure. This is also a reality that companies openly acknowledge. Rare earth supply chains are not environmentally neutral. Extraction and processing carry emissions, chemical use, and waste streams. And yet, corporations continue to depend on them, not because the footprint is ignored, but because the materials are functionally irreplaceable in many applications today. In other words, the decision is rarely clean versus dirty. It is possible versus not possible. This is why corporate strategy increasingly focuses not only on access but on supply and diversification, recycling technologies, and materials efficiency. The goal is not to eliminate dependence overnight, but to reduce risk and improve the footprint across the life cycle. From an operational perspective, rare earths behave less like a commodity and more like a system dependency. If supply tightens, the impact is not limited to one industry. It moves through manufacturing timelines, energy projects, electronics productions, and even defense readiness. That is why companies track these materials closely, not just as procurement items, but as strategic inputs. Because in a world moving toward electrification, automation, and digital infrastructure, rare earths are not simply components. They are enabling materials. And their flow through corporate supply chains is what turns geological resources into everyday functionality. Rare earths are not just a supply chain topic, they are market pressure tool. And the clearest signal of that power has already happened. In 2010, China restricted exports during a geopolitical dispute with Japan. Within months, prices for critical materials surged several times over. Manufacturers suddenly realized something fundamental. Access to key inputs could change faster than industrial planning cycles. That moment still shapes strategy today, and volatility did not disappear. Between 2021 and 2022, strong demand from electric vehicles and wind projects pushed prices sharply higher again. When demand cooled, prices fell back. This is the pattern. The market is relatively small but extremely sensitive. Its annual size is roughly 15 to 20 billion, yet it feeds industries worth trillions. Cars, energy, electronics, defense. So even small shifts at the start of the chain can ripple across the global economy. Major manufacturers are no longer treating these materials as a routine inputs, they are building resilience into supply. Tesla has been redesigning some motor technologies to reduce dependence on rare earth magnets where possible. Apple is investing in recycling programs, including partnership to recover rare earth materials from used electronics. Industrial groups like Siemens and GE are expanding supplier network to avoid single source exposure for turbine and automation components. Automotive companies across Europe and Japan are signing long term contracts directly with producers to stabilize supply and pricing. The goal is not independence, it is risk management. Governments now treat these materials as part of national industrial strategy. The United States is funding domestic processing through support for companies like MP Materials and new refining capacity projects. The European Union launched the Critical Raw Materials Act, aiming to increase domestic extraction and processing while securing supply agreements with partners. Japan, after the 2010 shock, invested heavily in overseas mining partnership and stockpiles to reduce vulnerability. Australia continues to expand production and processing through companies like Linas, positioning itself as a key alternative supplier. These moves are not about replacing China overnight, but they are about reducing single point dependency. So, investment is now moving into three main areas: new processing facilities outside China, recycling technologies, exploration of new deposits. For example, the US and Europe Union are both supporting new separation plants, while venture funding is increasing for companies developing magnet recycling and alternative materials. This capital flow signals a structural shift. Rare earth supply is no longer just a mining issue. It is becoming part of industrial security planning. China does not need to stop exports to influence the market. Regulatory signals, inspections, or production adjustments are often enough to move prices and expectations. For importing regions, this creates exposure. Inputs are external, but costs are internal. When global prices rise, the effect appears downstream in manufacturing costs, infrastructure budgets, and eventually consumer prices. In practice, volatility is absorbed by the economy as a whole. The direction is becoming more clear. Countries want partial independence, companies want multiple sourcing regions, investors want more resilient supply chains. Not because shortages happen every year, but because dependence is structural. And that is the key insight. These materials behave less like a commodity and more like a control point in the global economy. Control does not sit where demand is highest, it sits where substitution is hardest. So, what does this shift really mean? It is a signal to the market, a signal to every player in the chain. The equation is moving towards balance. The ball is on the other side now, and no single player is treated as the untouchable goat anymore. Companies are investing, diversifying, and redesigning supply chains to reduce dependence and build resilience. Because stability is no longer assumed, it has to be built. And this is what defines the next phase. The rare earth economy is no longer a narrow, concentrated system. It is becoming a truly global one. More regions, more capacity, more shared leverage. And right now, the direction is simple: from concentration to balance, from dependence to resilience, and from a closed system to a global industrial reality.